Welcome to the marking desk. I've been sitting here for about 6 hours staring at this digital portal as hundreds of Cambridge AS and A-level mathematics scripts load onto my screen. Specifically, we're looking at syllabus 9709. My scripts mark today counter is climbing, but my energy is dropping because I keep seeing the exact same tragic mistakes over and over again. Today, we're taking an exhaustive, behind-the-scenes look at something that seems incredibly straightforward on the surface, but consistently trips up thousands of candidates: trigonometric identities. Specifically, we are looking at two absolute foundational pillars. First, the fact that sine theta over cosine theta is identical to tangent theta. Second, that sine squared theta plus cosine squared theta is identical to 1. Now look, you probably know these formulas inside and out. You probably have them highlighted in your textbook. They are the bread and butter of trigonometric proofs. But here is the harsh reality from the other side of the screen. Merely applying them to manipulate a complex equation isn't enough. Doing it in a way that proves complete, undeniable mathematical fluency to someone like me, a chief examiner, is where the real challenge lies. Over the course of this explainer, I'm going to show you exactly how these two simple identities unlock advanced, high-tariff problems. More importantly, I'm going to pull back the curtain and show you how avoiding a few very common, very specific pitfalls can completely transform your script from a failing threshold right into the top-tier A-star marking bands. Here is our roadmap for today's masterclass. First, mark scheme anatomy. Second, cognitive domains. Third, the apprentice clash. Fourth, method mark strategy. Fifth, live marking audit. And finally, the final grading log. Let's not waste any time. Phase 1. Dissecting the mark scheme anatomy. All right, I'm pulling up a high-tariff, multi-part Cambridge past paper question on the marking interface right now. I want you to know a secret. I know exactly what grade a candidate is getting within the first 15 seconds of scanning their response. It's what I call the 15-second structure scan. What you're seeing here perfectly illustrates the massive divide between a weak mathematical approach and a top tier one. Let's look at candidate alpha. We'll call him Alex. Alex has a B-grade approach. When panic sets in during the exam, Alex recognizes a complex trig equation and simply dumps his textbook definitions onto the page, line by line. He literally just writes out that sine over cosine equals tangent and sine squared plus cosine squared equals 1, completely unorganized, just desperately hoping I'll award him some partial method marks. But a mathematical proof isn't just a grocery list of facts. Now look at candidate beta. Let's call her Sam. Sam has an A-star approach. She evaluates and actively bridges the gap using clear structural links. Instead of just stating the identities, Sam's response is an evaluative thesis. She realizes that an equation full of messy sine and cosine terms can be completely streamlined. She specifically shows the step where she divides through by cosine to create a single tangent term. Or she strategically substitutes sine squared theta for 1 minus cosine squared theta so that the entire ugly equation can suddenly be factored as a neat quadratic. She is showing me purposeful application, and that is exactly what I am looking for when my digital stylus hovers over the full marks button. Phase 2. Core principles and cognitive domains. Let's shift our focus to the theoretical architecture of the syllabus for a minute. The crucial point here is understanding exactly what these exam questions are actually testing. They are targeting 3 distinct cognitive domains, also known as assessment objectives. First up is knowledge and understanding. Do you know the identity? Yes, that's your baseline. That gets you in the door. Second is application. This is where you prove you know precisely when to substitute tangent theta for sine over cosine to eliminate variables in a chaotic algebraic fraction. But the third domain, analysis, is where the real heavy lifting happens. This is where I separate the good students from the great ones. Analysis is recognizing the cascading effect of your substitution. It's the moment a candidate realizes that applying sine squared plus cosine squared equals 1 can suddenly turn an unsolvable multivariable mess of trig ratios into a clean, easily factored equation. The absolute mastery of these identities requires you to hit all 3 of these domains simultaneously. You have to use your foundational knowledge as a razor-sharp tool for deep analysis. If you only show me knowledge, you cap out at a C. Show me analysis, and you're getting that A-star. Phase 3. The apprentice peer clash. I want to bring up a split-screen viewport right now. We recorded a live study session between our 2 candidates, Alex and Sam, debating how to structurally execute a model response for one of these exact questions. In mathematics, evaluative thinking is literally everything. It isn't just about aggressively pushing numbers around a page, it's about questioning your assumptions. So, I'm watching this debate and Alex is sitting there pointing at his paper saying, look, to simplify this equation, I'm just going to divide both sides by cosine theta so I can create a tangent theta term. It's faster. And on paper, sure, that looks like a decent move. But Sam pushes back. She stops him and says, wait, what if cosine theta is 0?
this is the brilliant moment. If the specific domain limits for theta in the question allow for cosine to be 0, Alex has just divided by 0, which is a massive mathematical violation. His entire proof would crumble right there. Sam argues that they have to explicitly state their domain limitations in the margin. She tells him, we have to justify our mathematical decisions with evidence, and she is absolutely right. Recognizing these subtle restrictions shows me, the examiner, that you aren't just blindly applying identities like a robot, but that you are truly evaluating the mathematical landscape of the problem. That's the difference between a dropped mark and a flawless paper.
Phase 4, mid-marking break and the method mark strategy. Okay, time out. I'm pushing back from the desk for a second. Before I grade this final model paragraph and show you the devastating mistake that costs thousands of candidates their A star every single year, let's secure your own academic trajectory. Hit the subscribe button for Ace the Exams at the handle @ace-exams right now, and turn on all notifications. Whether you are sitting for IGCSE, O-levels, AS, or A-levels, this is your direct channel to outsmart the marking desk. Okay, let's get back to it. Alex and Sam have hit a logical roadblock mid-argument. Their evidence has stopped supporting their conclusion. So I'm going to step in and deploy a logical framework that rescues failing argument strings. We call it the deconstruct, solve, evaluate sequence, broken down into 5 distinct steps. Step 1, identify key elements. I tell them to look closely at the equation and find the hidden opportunities. Do they see a sine squared term that could secretly be paired with a cosine squared? Step 2, apply relevant principles. Bring in the identities explicitly. Step 3, execute the analysis. Expand, factor, and solve systematically. Step 4, verify results. This is massive. Check your solutions against the given domain. Are your angles supposed to be in radians or degrees? Finally, step 5, present in proper format. If you format your working with crystal clarity, even if you make a stupid arithmetic error in step 3, I can still award you method marks because your logical string is intact. So Alex and Sam rewrite their paragraph out loud, line by line, deploying this exact sequence, and suddenly they've built a bulletproof top band response. Now, I know that under strict exam time limits, your cognitive load is absolutely immense. The pressure is on, the clock is ticking, and it is surprisingly easy to freeze up on the absolute basics. You might be tempted to build some wordy mnemonic for these identities, but let me give you the examiner-approved ultimate memory hack. The absolute best way to lock these down so you never panic is to deeply understand their geometric derivation. If you ever blank on whether tangent is sine over cosine or cosine over sine, stop and just visualize a basic right-angle triangle. Remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. If you divide sine by cosine, the hypotenuses completely cancel out, and you are left mathematically with opposite over adjacent, which is the exact definition of tangent. It's flawless. Similarly, take the Pythagorean theorem, a squared plus b squared plus c squared. If you divide everything in that equation by the hypotenuse squared, it instantly derives sine squared plus cosine squared equals 1. When you ground your memory in actual geometric truth instead of a catchy phrase, you free up your brain's processing power for the heavy, high-level analysis that I am looking for. Phase 5, interactive live marking audits. All right, I am handing my digital grading stylus over to you. We are going to do a live marking workshop right now. Challenge number 1, the 30-second data scan. Imagine you are looking at a complex, terrifying trigonometric expression on an exam paper. Something truly gnarly like 5 sine squared theta plus 5 cosine squared theta. If you are reading it slowly, piece by isolated piece, you are going to get completely bogged down. But if you've trained yourself to interpret causal relationships instantly, you look at that and immediately factor out the 5. So now you're left with 5 times the quantity of sine squared plus cosine squared in brackets. Because you know the core identity inside and out, you know that entire bracket instantly collapses to the number 1. The whole massive, complex expression simplifies to just 5 in a matter of seconds. That is the power of drawing an evidence-based conclusion quickly. Recognizing these hidden identities allows you to collapse massive algebra problems instantly, securing your velocity and keeping you ahead of the clock. Okay, keep the stylus. Challenge number 2, spot the penalty. This brings us to a highly accurate, incredibly common, and totally devastating mathematical error. A major trap when solving trig equations is improper manipulation. Imagine a student is faced with the equation sine theta times cosine theta equals sine theta. I see candidates, smart candidates, whose immediate instinct is to just divide both sides by sine theta to get cosine theta equals 1. It looks so clean, right? But the moment you do that, my digital red marker comes out. By dividing by a variable term, you have just completely erased a valid solution. You blindly assumed sine theta wasn't 0. The correct A-star method is to move everything to one side and factor it out. Sine theta times the quantity of cosine theta minus 1 equals 0. Now you have 2 completely valid solution paths.
When candidates miss this, it is considered descriptive fluff or a logical break, and it forfeits up to 5 critical marks instantly. Precision in your algebraic steps is absolutely non-negotiable. Let's look at exactly how these conceptual errors translate into objective, fatal flaws on my screen. These are pulled directly from principal examiner reports. Flaw number 1, missing proper format. This breaks my heart to see. It often looks like a candidate casually dropping the squared symbol on their sign terms midway through a long proof. Just getting sloppy. That completely invalidates the Pythagorean identity and ruins the rest of the calculation. Flaw number 2, poor presentation. When you substitute sine over cosine for tangent, failing to cleanly write out your complex, multi-tiered fractions can lead to your brain tricking you into multiplying when you should actually be dividing. It's a visual formatting error that causes a mathematical failure. Flaw number 3, answers not specific to context. If the question explicitly asks for theta to be between 0 and pi, and you go ahead and calculate brilliant, perfect solutions for 2 pi, you have completely failed to evaluate the evidence quality. Your math is flawless, but you ignored the context, so I cannot give you the marks.
Phase 6, the final grading log. Alex and Sam have finally assembled their completed, flawless response paragraph, avoiding all the pitfalls we just discussed. I am officially logging a perfect full-mark score into the Cambridge system for them. To distill this entire explainer down, achieving true mathematical mastery with these trig identities relies on what I call the 3 universal marking truths. Truth 1, the 15-second structure scan. Your proof absolutely must flow logically from one step to the next, with clear formatting and hyper-accurate notation right out of the gate. Truth 2, the mark per minute velocity rule. This is about methodical substitution. You cannot afford to just move terms around randomly hoping something works. You must strategically use sine over cosine and sine squared plus cosine squared to eliminate variables with ruthless efficiency. Truth 3, the final quality review pass. Do your final angles actually fit the specific domain of the question? Did you double-check that you avoided dividing by 0? Applying these 3 truths consistently is exactly what elevates a basic textbook understanding into an elite, top-band application of mathematics. So, as I clear my desk for the day, I leave you with this final provocative thought to ponder the next time you face a gnarly trigonometric proof on an exam. Are you just solving the equation blindly, crossing your fingers and hoping the numbers eventually work out? Or are you actively deconstructing the problem, critically evaluating every single substitution, and maintaining absolute, unwavering control over the mathematical domain? Keep practicing, question your assumptions, and master those identities. Before you go, make sure you are subscribed to the channel at Ace the Exams and click the notification bell so you never miss these weekly examiner breakdowns. And right now, I want you to head down to the comments and leave a message stating your subject, your qualification level, and your exact target grade. I'll see you in the next explainer.